नमस्कार मित्रों, आज हम मैट्रिसेस की चर्चा करेंगे। मैट्रिसेस क्या होता है? मैट्रिसेस इज अ रेक्टेंगुलर रिप्रेजेंटेशन ऑफ एम एन नंबर्स वेयर नंबर्स आर रियल, कॉम्प्लेक्स, रेशनल etc इज नोन एज ए मैट्रिक्स रिप्रेजेंटेशन। अर्थात मैट्रिसेस क्या होता है? एक आयताकार सारणी के रूप में नंबरों का एक प्रदर्शन होता है। वो नंबर वास्तविक संख्याएं, समिश्र संख्याएं, कुछ भी हो सकती हैं। In general, those numbers which form matrix are written as by the notation here. There are so many representation of matrices, that is this bracket and this bracket or this modulus. Usually matrices we represented by matrices with capital letters such as A, B, C, etc. Now the mn numbers of matrix, which are also known as elements of the matrix, are positioned into the different rows and different columns, such as we represent the matrices in rows and column, such as this is first row, this is second row, and so on. And we represent this by column, first column, this second, third, and so on. If matrix has m rows and n columns, then we known as it is m cross n matrix of m cross n order. That is, ith rows, jth columns, positions of a matrix A is denoted by a small letter Aij, and a matrix A of order m cross n can be written in short as A equal to matrix of Aij, where order of matrix is m cross n, that is order of matrix, that is m cross n order matrix, where I and j, here I lies from 1 to m, that is row, and j lies from 1 to n. Now we let us example of a matrix of order 2 cross 3, that is a matrix A equal to Aij equal to 2 cross 3. The matrix A is defined as such as A of Ij equal to I dot j. Then we write the matrix in the rectangular form, such as here by definition A of Ij equal to I dot j, that is the matrix is represented in rectangular form for 1 1, that is I and j equal to 1, then I 1 into 1 equal to 1. Now for 1 2 element, here matrix is 2 cross 3, then 2 rows and 3 columns. Then second element, that is 1 1 element, 1 2 element, by definition I into j, that is 1 into 2 2. Now 1 3 element, by definition I dot j, we obtain here 1 dot 3, that is 3. Similarly A 2 1, by definition 2 dot 1, that is 2, and 2 dot 2, that is 4, and 2 dot 3 is 6. Then the matrices capital A is written as 1 2 3 2 4 6, that is 2 cross 3 matrix, because the rows are 2, that is first row, that is second row, it is first column, it is second, and it is third column. Matrix over any field F is defined as, we denote it, the matrix A equal to Aij, where the element of the matrix Aij belong to a particular field F, whose each element belong to particular field F is known as F matrix. Known as F matrix. Here F means field, that is F means field. Unless otherwise stated, a matrix is understood as complex matrix, because complex matrix is the big field. That is, if a matrix is given and the particular field is not then we take complex number as a field of matrices, that is matrices over the complex. Now we see that when two matrices are equal, that is equality of two matrices. Here two cases of the equality of matrices. The first one is two matrices are comfortable for equal if they are of the same order. That is, if we take a matrices A equal to Ij, where the order of matrices is m cross n, and we take another matrices, that is B equal to B of Ij, and order of this B is equal to order of this A, then we say that the matrices A may be equal to matrices B. The second property for equality of two matrices is two matrices are said to be equal if and only if their corresponding elements are same. That is, if we take A equal to Aij, that is the second case, we say that the matrix A equal to Aij of m cross n, and B equal to the matrix Bij of m cross n, that is order of both the matrix are same, then we say that the matrix A is said to be matrix B if and only if the corresponding element of both the matrices are same. That is Aij equal to B of Ij for every Ij. Now we take a example of equality of two matrices. That is, question is, which of the following matrices equal if matrices are tabular from Z3 field, that is the field is modulo 3 field. Here what I do, I will show that this matrices 1 0 1 minus 1 is equal to 4 of these matrices, and we know that this matrices 1 0 1 minus 1 is modulo 3 field. For this we check first matrices 4 3 7 8. Now this, for 4 we divide 4 by 3 and get remainder 1, and we divide 3 by 3 to get remainder 0. Now we divide 7 by 3 to get remainder 3 2 just 6, that is 1, and when we divide 8 by 3 we get the remainder 3 2 just 6, that is 2. 2 is nothing but near about equivalent to -1. When we subtract -3, we get -1. Then this matrices first 4 3 7 8 is equivalent to 1 0 1 -1. Then it is clear answer. Now we check the second matrices, that is 10 9 8 10 and 8. This is equal to this matrices 1 0 1 and -1. For this we check this matrices is equivalent to 10. When we divide 10 by 3, we get the remainder 1. When 9 is divided by 3, we get the remainder 0. Here when 10 is divided by 3, we get a remainder 1. When 8 is divided by 3, we get a remainder -1. Then we say that 1 0 1 -1 is equal to 1 0 for this matrix, and the second answer is also correct. Now we check third matrices 1 0 1 2 is equal to this matrices or not. For this we say that 1 is equal to 1, 0 is equal to 0, 1 is equal to 1, and 2 is equal to -1, because when we subtract 2 by 3, then we get -1. Then 2 is nearly equivalent to -1. Then third answer is also correct. Fourth answer is known. Hence we see that this matrix is equal to these are three matrices, that is first, second and third. Let us another example for equality of two matrices. The question is, for what value of AB C5 is equal to D3 4 6. That is we have to show that this matrix is equal to this matrix. For equality of two matrices, we know that first we check the order of both the matrix. Here the order of both the matrix is 2 cross 2, that is order is same. Now we check the corresponding elements are same or not. For corresponding element we see that A equal to D, that is it may be A equal to D, B equal to 3, that is B equal to 3, C equal to 4, that is it may be C equal to 4, but we cannot say that 5 equal to 6, because it is never possible that is 5 equal to 6. Then we say that here the matrix A is not equal to B, because the corresponding element 5 and 6 are not equal. Now let us second question. For what value of this matrix is equal to this matrix? We first check the order, both are same order, that is 2 cross 2. Now we check the corresponding element of both the matrices. Here we say that A equal to D. If the matrices A is equal to matrices B, then the corresponding element A equal to D and B equal to 3, C equal to 4 and D equal to 5. If both the matrices A and B are equal, then the corresponding element are same, that is A equal to D, B equal to 3, C equal to 4 and D equal to 5. Now we read zero matrices. Zero matrices are, we say that, null matrices. The definition is this: a matrix A of order m cross n is said to be a zero matrix or null matrix or bad matrix if each element of the matrix is zero. That is, a matrix A. If we write this in small notation Aij, that is order of A is m cross n, then we say that A is zero matrix if every element of this matrix, that is Aij, equal to 0 for every I and j. It is also denoted by zero matrix, that is 0, and order is written as under this, that is zero matrix of order m cross n. Now we read another matrix, that is called row matrix. We also know this matrix is a row vector. By definition, a matrix containing one row and any number of columns is known as a row matrix. It is also known as row vector. That is, for example, we say that, for example, we let a matrix A such as 1 0 minus 1, that is 1 cross 3 order, that is 1 row and 3 columns. Then this matrix is said to be a row matrix because here only one row is present and there are so many columns. Another example, 1 0 minus 1, that is 1 cross 3, etc. There are so many row matrices in which the only one row, such as row matrix. Similarly, we defined column matrix. Column matrix or column vector, that is a matrix containing one column and any number of rows is known as column matrix or column vector. By example, we see that here the number of columns equal to 1. We let a matrix A such as 1 2 3 and 4. Here we see that the order of this matrix is 4 cross 1, that is the column is 1, and there are so many rows, that is first row, second row, third row and fourth row. There are fourth rows but the columns is only 1, so this matrix is a column matrix because the number of columns here is 1. Such as in row matrix, that is the number of rows is 1. Then it is a distinction between row matrices and column matrices. Now let us another types of matrix, that is square matrix. It is clear to name of square matrix, a matrix in which the number of rows and number of columns are same is known as square matrix. That is, a matrix is a square matrix, that is A is a matrix. We denote A equal to A of Ij. Then A is a square matrix if the number of rows and number of columns are same, that is m equal to n, that is number of rows equal to number of columns. Then this matrix is said to be a square matrix. If a square matrix whose number of rows and columns are n, then if a matrix whose rows and columns are n, then this matrix is a matrix, a square matrix of order n. that is a matrix of order n. Let a small example of a square matrix. We let a 2 cross 2 matrix, that is 1 6 2 7, that is 2 cross 2 matrix, because the number of rows and number of columns are equal, that is 2 and 2, then we say that this matrix is a square matrix. Now if a matrix of order n cross n, here we let a matrix A of order n cross n, and we write all the elements of square matrix n cross n, that is a11, a12, a13 dot dot dot, a1n, a21, a22, a23 dot dot dot, a2n. Similarly, the nth column is, nth row is an1, an2, an3 dot dot dot, ann. That is a matrix of order n cross n. Then in a square matrix of order n cross n, whose number of rows, elements and number of column are same, is known as diagonal element. And this element in which number of rows and number of columns are same, that is 2 2 1 1, that is row and column are equal, are said to be diagonal element. In which number of rows and number of column are same, that elements are called diagonal element. And the line along which they lie, this line is called diagonal line, and we know that it is a principal diagonal of the matrix, that is this line is called principal diagonal of the matrix, that is principal diagonal of matrix, diagonal of matrices. Now we see that in a square matrix of order n cross n, how many diagonal element of the square matrix n cross n. Here we see that in a first row and first column there are only one element, in second row and second column there are only one element, in the third row and third column there are only one element. Similarly, all the rows and column containing one diagonal element. Hence it is clear that in n cross n square matrix there are n diagonal element, there are n diagonal elements.